You can read Barack Obama's climate action plan. There are many very good ideas, which are a huge fraction are unrealistic. Really bright ideas, but it will take centuries to get them realistic. It's ideas like to go on with methane, natural gas production, but just to capture all the leakages, make kind of umbrellas, tents above each pipeline, make small power plants directly to the pipeline to just on site burn the leaking methane and things like that. There's a huge potential to avoid this kind of emissions through the methane. So this would for me be a message. Methane is a good thing, but you have to be careful. Gas is cleaner by 60% and oil production is cleaner by 80%. You know, from oil production also some natural gas is emitted to the atmosphere. So it's cleaner. Issue would say, oh, we stop coal burning, we should switch to methane burning. And it would be very good to have this modern, non-conventional technique like fracking, you know, from the newspapers, because all the old sources have become empty, but this new unconventional fracking mechanism, you can come to new sources of natural gas. So the problem is this budget consideration that natural gas is cleaner in terms of CO2 produced. So methane burning produces less CO2 than coal burning. This is an error. It's just a consideration of CO2 produced by the burning. I forgot in this consideration that you have to transport the methane, the natural gas, from the drilling to your power plant. You have a pipeline. And also the drilling, you have diffuse emissions, leakages. And this consideration that the coal the methane is cleaner, the natural gas is cleaner, this consideration breaks down if we think about a leakage rate of about 3.2%. That's the break-even point. There is a paper by Alvarez 2012. He has calculated this. If you have a total leakage rate of around 3%, then you come to a point where you should say, oh no good idea is methane. Coal burning is still better. Why? Because if you have a leak on your pipeline, the methane directly goes to the atmosphere, and you should know that methane itself is a much stronger greenhouse gas than CO2. A factor of 50 or so, a stronger greenhouse effect per kilogram emitted. If you emit 1 kilogram methane and emit 1 kilogram CO2 to the atmosphere, the greenhouse effect of methane is a factor of 50 stronger from methane. We just have much fewer methane in the atmosphere right now. So the effect is quite strong. So these small leakages matter very strongly, and the problem is we don't know exactly how big, again the question of numbers, how big these leakages are. So the EPA, Environmental Protection Agency of the United States, has published as an annual report. In 2014 they published that the leakage rates are roughly 1.2% for natural gas and 0.7% for oil. Every time if you produce oil, some methane or natural gas is emitted. So 1%, you're well below this break-even point of 3%, where you should say, oh, coal would be cleaner. So it's on the sure side. Now we started first experiments to look how huge these leakages really are. What they did, it's called bottom-up approaches, like the EPA. What they do is that they go with a nozzle, a sensor directly to the pipeline, directly to the well where the drilling is, and measure at some spot. And then they make an extrapolation. If it would be similar in other spots, they end up with these numbers they publish. It's easy to make an error. If you have a local source, the source may be a factor of 100 stronger just 20 meters away, because it just missed the leakage in the pipeline. That's a big risk. And the only way around is to make this kind of top-down approach. This would be bottom-up, to look and extrapolate. Top-down would be to look at the satellite image. 1 minute satellite image. So you get here, for example, measurements after year 2008 and measurements before 2008 and the ratio. You see in the United States in several fracking areas how strongly the methane, in yellow, strong methane, the methane emissions increased. And in this studies, it's a friend of mine at the University of Bremen, Oliver Schneissing, he published leakage rate was here and here roughly 10%. Well above this break-even point of 3%. So what we found, working on the ground with our sensors at the Zugspitze with an FDR instrument looking up this trend. What we measure is the integrated column of methane in the atmosphere and over many years. And it's like Dobson units for ozone. It's just the integral of all the molecules in the atmosphere. You see it's been quite constant, but in the year 06 to 07 we had a strong renewed increase. The question is, what's the reason? Remember, a factor of 50 stronger greenhouse gas, methane compared to CO2, so it's really critical to see this renewed increase, and we have to try to understand where it comes from. So there are two candidates, biogenic emissions like cows, you know, from the stomach, bacteria, anaerobic processes produce methane. Wetlands, the same thing, biogenic emissions, rice fields in India, in Japan, they're strongly increased. You have this kind of feedback. If you make the climate warm due to CO2, in a warm climate there is more of this biogenic production. So that's one candidate. Another candidate is, of course, natural gas production, drilling, fracking. The fracking probably produces more leakages because you make cracks in the rocks. So it's, the question is, we just see a trend. That's the response function in the atmosphere. The reason is, what's the underlying emission? We just are working with a PhD student on the following plan. We have a similar time series, not for methane, but for ethane. Ethane is only coming out of germogenic methane, which is drilling from the inner of the earth. Ethane is not at all coming from biogenic sources. And we looked at our trend, and we have a qualitatively quite a similar behavior. We have this jump to a renewed, strong renewed increase just at the turn of the year 06 to 07. So there's an indication, oh, something happened. People started to do more natural gas production. And if we go to the history in the States, we just started drilling 10 years ago, roughly. And that's qualitative. Now we have to come to the quantitative point, of course. We now have the slope of the ethane, and the ethane comes out of the fracking, of the drilling. The slope of the ethane, and try to calculate with a simple box model for two hemispheres, which percent of this renewed increase, the slope, which percentage, which fraction of the slope can be explained by natural gas emissions or thermogenic emissions. So probably not all. Something maybe to increase biogenic emissions, but we can then give a threshold. There is a significant and certain part due to the increased natural gas production. So that's my end. Thank you so much. And you're all